The component challenge the reporter with the question, with the problem.
Okay, and I want to oppose the carbon 6 non-contact resistance.
6.
We accept the challenge.
Reporter, write down your paper. The reporter have 5 minutes to prepare next stage. Okay.
Honorable juries and fellow competitors, a reporter from Team Harvard from Jinshan High School. And today I'm going to present problem number 6, non-contact resistance. So here's the problem statement which requires us to investigate responses from the RLC circuits driven by an AC source. And it will be changed, the response will be changed by a non-magnetic metal rod or a ferromagnetic rod into an inductor coil. And how can we obtain the magnetic and electric properties from the responses? So this is the main point. What will be the most important part of the circuit that plays the main role in the phenomenon? And also, how can this circuit be used as a measurement to the rod? So here's our content today. And first, let's go into our observation. In our observation video, we can see that,
You might have to go
No,
out.
the rod is pulled out and the rod is put in. The peak to peak value of the AC voltage has a change. And so this is a point that we are going to discuss and investigate during our presentation, where we can give a qualitative explanation that in an RLC circuit, there is 3 components, and these 2, which is the capacitor and the resistance, won't change. But the inductance, which will be in fact impacted by the rod's insertion. And when the inductance is changed, the resonance frequency of this circuit will be changed, and that is how this phenomenon will be happening. So here is our theoretical model. First, let's see what is actually a LRC circuit, and we also have our simulation presented. First, we install it in resistance, and we next install an inductor on it, which we can observe a clear phasor difference between the voltage and current, which is produced by the inductance of the inductor, and which is the phase shift. And also, when the capacitor is added, those 2, the capacitor will also give a phase change, which we'll discuss later, and the reactance of the whole circuit will be changed, so the amount of current will be smaller. And so here we'll be discussing the phase change from the capacitor, that the capacitor will produce a phase change forward 90 degrees because the derivative of the currents on the capacitor will lead to the current, which there is the electrical charge, and we can derive it into the current, which is by derivative of time, and we can get this formula, which when we change it into cosine presentation, there will be a 90 degrees of phase change. And when it comes to the inductor, that from the derived formula, the currents will be from the integration of the inductor's performance, and there will be a minus 90 degrees phase change, and which is the most important factor that causes the whole phenomenon today, where we have the capacitor has a 90 degree change and positive 90 degree change, which will lead to an impedance in the voltage, the instantaneous voltage calculation. So, which will be the most important factor today related to resonance frequency. And so, when the currents need to be resonance, therefore the impedance need to be cancelled so that the voltage can reach to the maximum value. And when the impedance is cancelled, it will be the formulas of the resonant frequency can be derived by this type, and which when we have applied a frequency on that, and therefore the phase is cancelled, the phase change is cancelled, and also the current and the voltage is on the same phase, and the current is bigger due to the impedance is cancelled. So let's redefine our problem statement again. We insert a non-magnetic metal rod and a ferromagnetic rod so that we can get the magnetic and electric properties of the rods from the circuit's response. And what is the response? Here, reporters think that it's about the resonance frequency, and the magnetic electrical properties will be the relative permeability and also the conductivities remain for the magnetic and electric. So we can first get the resonance frequency, and then we can calculate the inductance from the first frequency's formula to acquire the relative permeability, and we can also acquire conductivity from calculation. So here will be the inductance calculation, where we'll be leading to the calculation of the from the inductance, and it will be leads to the relative permeability of the rod. And also there will be two electromotive force on the circuit, because on the inductor there is self-inductance electromotive force and also the applied voltage, which will lead to the electromotive force on the rod, and it will occur a current, so that therefore the voltage value is changed, which we can get the conductivity. And here will be our experimental setup. First, we have signal generator, ROC components, and that's the components we use for resistance and capacitors. And we have various rods to be examined, and we have oscilloscope. And the procedures will be set up the inductors needed, and we can start a record of peak-to-peak voltage on the oscilloscope. And we can adjust the signal frequency on the signal generator, so that we can record the voltage value under various frequencies to spreadsheets, and we can get the resonant frequency to do the calculation. So here's our first for the relative permeability. Because relative permeability can only be obtained under the ferromagnetic rods, so that we only use ferromagnetic rods for this experiment. And from the formulas that support our experiments, that we can get the resonance frequency from the circuit's response, that when the voltage reaches to maximum value, there is the resonant frequency. And there is the inductance comparison between the calculation and the exact measured value from the rod. And from the only coil part, there is only a small deviation, but when the rod is inserted into the inductor, the deviation becomes bigger. And here we can use the inductance to calculate the relative probability from the formula. And when the average deviation is smaller when there is only coil from the inductor. And for our short conduction from the experiments, the inductance can be derived from the resonant frequency, and also the relative permeability can also be able to calculate. And only ferromagnetic rods can change the inductance due to its relative permeability. And the deviation is larger on inductors having a rod inserted. And for the conductivity, we can observe from various conductor types that we install some like 600 rounds and 600 rounds with aluminum, charcoal, and other materials inserted. And we can observe that the charcoal part doesn't have the conductivity to applied. The impedance, the reactance, the charcoal didn't change the reactance of the inductor. And also here is the measured conductivity value from the exact material. But that's strange why the charcoal won't have the inductance, won't change the reactance on the inductance. And we'll be discussing that later. So for the short conduction, the conductivities can be observed from peak to peak voltage variation, and the detailed theory need to be conducted for the calculation of conductivity. And the charcoal didn't produce reactance on the inductor, but still having conductivity. For a conclusion, there will be some deviations that we need to discuss. That why the resonance frequent voltage variation from like only coil and when the rod is inserted. Because from the impedance formula, that the impedance is dependent on the frequency that we applied on it. So here the reactance will be smaller, and which this will be bigger. And about the relative permeability variation, that we have found a thesis support this one, which the gap between the metal rod and the coil will cause deviation on impedance, So that will lead to different phasor difference, and that is what affects the calculation results and the experimental results. And why the charcoal's conductivities can be examined, but it doesn't produce on our experimental data, it's because we think that charcoal rod is performed by a single layer molecules, and the copper rod, like other materials, aluminum, copper rods, they are complex structure, which the eddy currents cannot flow more smoothly on the charcoal rod, which the phenomenon may be not that clear, but maybe there will be phenomenon, but because of the eddy currents, it's not performed correct, so there the phenomenon is smaller. And about the interesting fact that we found, that the ferromagnetic rod will produce a high frequency sound at 300 hertz, 1300 hertz. The reason might be the Joule's magnetoresistance at our imagination, where the Joule's magnetoresistance is because when we apply a magnetic field on the rod, that it will the flux will affect the performance of the particles on it, and it will change so that when it reaches the resonant frequency of the rod, it will perform an acoustic sound that we can hear. So for the conclusion, for the problem statements, the responses of the circuits will be the resonant frequency, and for the we can get the relative permeability. And also, non-magnetic metal rod or ferromagnetic rod, we can change the impedance will be changed, and the inductance will be changed also. And for the magnetic and electric properties, that we can get the relative permeabilities and conductivity. And for the conclusion, relative permeability can be measured by our circuits, but there will be a deviation. And for conductivities, they can be observed from the peak to V voltage. And from ferromagnetic rods, it's observed to produce a high frequency sound at specific signal frequency. And that's all of my presentation. Thanks for your time.
Good.
And I want back to the question. Can you indicate before?
Yeah. So
and there are capacitors that you use a capacitor, right?
Yep.
And do you know the capacitor has two kinds? And one is for AC, one is for DC, and which kind of you use?
Yeah, of course we get the AC.
Okay. And can you turn to page 28? You say you insert rod, and what is the rod material?
Oh, here we got our ferrite rod and also a rod that's performed by a
And you say the copper and the charcoals have made the eddy current, right?
Yeah.
And using the ferromagnetic rod and also can make the eddy currents?
Oh yes, of course.
Okay. And you say ferromagnetic rod is make the inductor bigger because it's permeability, or it's make the more
the inductance will be bigger.
So it's make the permeability is more in fact more.
Yeah, of course.
Okay. And you can page next your theory part about the inductor.
About the inductor is one. Yeah, yes.
Okay. And so at this week we use the LRC oscillations and add the AC source, right?
Yes.
And how does AC source affect about the LRC circuits?
Oh yeah, so the AC source will provide the frequency of the circuit.
Okay. And that's all.
Okay.
Now, Puna had 3 minutes to prepare. 3 minutes to prepare.
Được 2 sẽ có thể tỉnh ra tại 问题。签给。channel。好。
Okay.
Okay, first thanks for the reporters presentations, and there's my text review. And there's problem statements. The response of the LRC circuit driven by the AC source, and they can change by inserting non-magnetic or ferromagnetic rod into the coils and obtain its properties. Okay, and the reporter used a theory of the LRC oscillations and use the permeabilities and say the permeability about rod and inductors, and also say the insert rod and conductive, and use the AD current to say. And about the experiments, he used an oscilloscope to find the voltage, and also use the voltage meters, and to detect the initial inductance and the capacitance, he used the LRC meters, and use a single generator act as the AC source. And the reporter's strength is that he has a completely quality phenomena explanations, and he do a lot of experiments to prove it, and have a good experiment setup, and clearly explain magnetic properties and conductive AD currents. But he lack of explanation of the experiment result, and he not match the theory model. He didn't say when we insert rod properties about an inductor's change, and he lack of physics picture or simple explanations on the phenomena. And he just talked about the permeabilities and conductive. So I think there have a lot of properties can discuss. So let's start to discuss. Oh, and can you page to 32? 32, yes.
Oh yeah, okay.
Okay, and so you just insert the rod and the rod size and about the cross area and the length is the same?
Yeah, we try to make it match the size of the coil.
Okay. And so, and when you try to use the same materials and the same cross area, but the insert length is not the same.
No, the insert length is also the same.
But, so, and you try not difference insert length about the inductors.
For this part, in the reporter's opinion, because as we read the problem statement, it just requires us to get the two magnets and electric properties from the rod. So we didn't do more accurate experiments to examine different lengths of the rod to lead to different consequences.
Okay. And do you think have another magnetic properties about the rod? Can you try to explain it? Some different properties about the rod? Or
well, as my thoughts, for the magnetic properties, the first comes to mind will be the relative permeabilities, which provides the ratio between the magnetic flux that can pass through the rod. So, and we didn't consider other properties.
So you think the phenomenon is based on the relativities, probabilities about the rod, and they make the inductor flux density change, so it makes the inductance change, right?
First of all, yeah, the impedance will be changed, but that is not the most important factor in that part of experiment, because the more important part is going to be the inductor's inductance, which will be affected by the relative probability inserted. So when the inductance change, the resonance frequency of the circuit will change.
So this model is only work on the ferromagnetic rod, right?
Yeah, because other rods, they are non-magnetic, so they won't have permittibility.
So can you definition about the ferromagnetic or another, like a paramagnetic or a diamagnetic? Can you definition about it?
Sorry,
Okay, and can you also turn to page 32, right? And like copper, and copper is a diamagnetic material, and aluminium is paramagnetic materials. And do you know these materials, like paramagnetic and diamagnetic? Can you know it?
For our experiment, because problem statement only says ferromagnetic, so we didn't do the research about this part, which is our mistake, that it can be a more interesting fact to discuss. So we would like to ask the reporter to explain it to us.
Okay, and about it, and Jerry, and can I use the blackboard? And like aluminum is paramagnetic, and when hit in the magnetic field, and there is a magnetic field, and you will make the magnetic field like this. Okay, it's paramagnetic, and the copper is diamagnetic. It will make the flux density become smaller, and it will also make the eddy current to against the magnetic field, like. So, and about the paramagnetic, its definition is permeability is bigger than vacuum probabilities, right? And like this, and the diamagnetic is smaller. And so, do you know the effect about it? And can you consider about this, or the conductive about this material is much affect more?
Oh yes, so if it's inserted, from our experiments, though we didn't see the resonance frequencies for those rods, and so that's why we don't consider it as a ferromagnetic rod. But since the reporter mentioned this point, that when it comes to the inductance formula, we can ensure that, well, the permeability change will sure change the inductance change, and that is a more interesting part to discuss.
And I also want to about AD currents, and I say the diamagnetic rod can make the AD current, and I'm interested about how and which materials can also make the AD current.
Like those the materials from reporter's view is about the materials that the electrons can pass through, and it will make the eddy currents come through on the material.
Okay. And so the eddy currents will make the inductance bigger or smaller. And in my opinion, I think the eddy currents can induce a new magnetic field and make the original flux density smaller, so make the inductance small. And how about you?
Yeah, and this part, the reporter agrees with the opponent, thinks that from the reactance formula, there from the eddy current that will produce another impedance on the circuit that is external from it. and that will truly change the results.
And so in this experiment, the component of the LRC circuit, so when insert a rod, it's just only interfere with the inductor, and the resistance and capacitor is not affect about the insert rod.
Sure. From the theoretical model and observation, we didn't see that the rod will affect the capacitance or the resistance of the resistor.
And about the resonance frequencies. So the resonance frequency is about the 2 pi and 1 over 2 pi 1. Yes. And so how do you get it?
Oh yeah. So from this formula, when the impedance need to be cancelled in order to reach the peak voltage, that the omegas, which is the angular frequency that can be this to this side and LD to this side, and we can get the part which there is the angular frequency. We need to divide it into 2 pi to get the results.
And interesting about how do you get these formulas, and by the
so
do you have any equation about it?
So from the part of the current, that here is the capacitor's current, there will be this listed like this, and the equation of inductor, which when we are calculating the sum of the voltage, which is the instantaneous voltage, there will be the currents will be taken out, and there will be R square and other impedance components.
And I think about the ferromagnetic rod have some properties. Can I introduce to you?
Yeah, sure.
Okay,
Please.
I also use background. And about the ferromagnetic rod has when the ferromagnetic rod in the magnetic field, and we will make so we take it out with the magnetic field, and the ferromagnetic rod like a magnet, right?
Yeah.
So the ferromagnetic rod become the magnet, and they have a flux density, right?
Yeah.
And do you think this phenomena will affect about when we insert the inductors?
Oh, sure. So there is something called I forgot it, like this curve's name, but as you mentioned, the flux of it need to be cancelled before our experimentation, or otherwise it will truly affect impedance.
And
Here I agree
you
with you.
want to try to make the flux density is not zero?
So
insert it.
yeah, we can do before our experiments where we let it experience a certain temperature, like the temperature that will cancel out the magnetic flux on it.
But the temperature will make the ferromagnetic rod flux density zero is not very high or not?
Yeah, it's
So you use a very high temperature to cancel its flux densities.
yeah, we only use like some fire to light up it.
It's pretty interesting. And about can you but in these conditions, and the ferromagnetic rod have remain flux densities, and how does the remain flux densities affect about this response of the LRC response?
Oh yeah, so there will be another impedance term if there is still remains magnetic flux. Yeah, and I agree with you that it will reduce the voltage since the resistance is turned bigger. Okay, thank you. Thank you.
And that's all. That's all. And I will
Okay.
go to
Go to the next stage.
Okay, first we use the we talk about the probabilities of the rod, and they have a new about the paramagnetic and diamagnetic and ferromagnetic definitions, and also use the flux density of the iron of the ferromagnetic can be a new parameter of this response, and we also use the top AC and DC capacitor of in this. Okay, and that's all. And
Okay, the reviewer calculus enter and ask the question. Okay, 14 minutes.
So I want to first ask your opponent, like, can you explain how does the system work and how does it affect the result of the experiment?
I think just only talk about the probabilities of the rod, and the probability and the paramagnetic rod will make the flux density bigger, so it will make the inducement bigger, and the diamagnetic rod can make the flux densities bigger and smaller, so you will make the inducement smaller.
So for the reporter, as the experiment and calculations conducted by you are mostly done by people in the past, so are there any creative theories or formulas that can be demonstrated by your experiment?
So since the LRC circuit is a phenomenon that is investigated before for a long time, so we can only find out something interesting like the rod's natural frequency and its resonance under certain voltage frequencies.
And like you mentioned very many formulas in the beginning of the presentation, so how could the different factors change the formulas?
The different factors for this experiments, the reported thing is about the inductance, and it is about relative permeability. And for the conductivity, it comes to the impedance of the circuit.
Okay. The reviewer has 2 minutes to prepare.
TYPT 吗？啊。这是他们笔记，对吧？他们俩保了几对吧？好，3，我现在要几道？
Reviewer, you have 4 minutes to report.
reporter's performance, we think that he had clear theoretical representation with both model and calculations to support his claim, and he had rich contents with enough content and information, and he conducted several experiments to prove the formulas, which is very good, and he explained the question accurately. However, there are more theoretical-based formulas instead of experimental-based, and the time management is not good because it's a bit rushed at the conclusion, which decreases the delivery of the presentation. In addition, he has a lack of simple phenomenon explanation and a lack of creativity and innovation. So for opponent's performance, he has questions the part that we are also confused, which can help decrease misunderstanding. And his time management is good because he controls the amount of questions asked. However, some questions are not detailed and the first question repeats the reporter's presentation. And he did not catch the main points at the beginning of the discussion because he's only asking about facts. So for the discussion part, the first question is is the circuit AC or DC? And the reporter answer is AC. But this question is pretty obvious and it's a known fact, so we think it's unnecessary. So the next one is that what role does AC circuits play in the experiment? And we agree with what the reporters answer. So the next one is a question about the resonance frequency. And the reporter explained the variables and the calculations in the formula. However, although the reporter can explain the formula really well, he fails to connect it with the real-world experiment. So this is our thoughts. Thank you.
Thank you. And report, take the final report.
So for our concluding remarks, there will be several points where the opponent discussed with me about different rods types that we didn't examine, which didn't go under the problem statement, but we can done it in the future work, like the paramagnetic and the diamagnetic parts. And for the remaining flux of the rod, we should be cancelled totally, as the opponent said, that there will be still some remaining flux, even though the rod reaches a high temperature. That we totally agree with that, and that is a future work that we can do in the future. And for the varying parameters that are discussed, and we are discussing those well about the theoretical parts and also our rod's material parts. But there are some future works that can be done to reduce the deviation, like for rod's properties, and for maybe some interesting facts like the other rods type, as the opponents has raised about the paramagnetics and other types of rods, and why, like the opponent said, the aluminum won't affect the resonance frequency. It's an interesting fact to discuss in the future, and that we can do more about the investigation in order to do a more clear investigation about this phenomenon. Thank you.
Question for the jury.
A question for three. If you insert a rod inside
Yes.
your RLC circuit, what changes? R change, L change, C change, or
The
which doesn't
inductance, which is L.
just change it? Okay. What about that?
I also think about it, it's just only the inductor will change.
I think only the inductor.
Okay, I have a, go ahead.
The question want you to look at the non-contact resistance. Are you making many efforts to look at the resonance? What the connection is good?
Because the inductance is changed, so the resonance frequency will be changed from the change of the inductance. And we can use the graph of the change to get the resonant frequency in order to get our inductance of the circuit, and we can calculate the Rod's property. And that's what we thought.
To look at the resonant can make the resistance.
About the resonant frequency.
Yeah.
And I think when we insert the rod, and so they make the inductor change, and the inductor change will also make the resonance frequency become different.
I think the change in the inductor will affect the resonance, so it's vital to be put in the presentation.
I have a question, but I have never been to answer. I don't know the answer either. The problem is, if I put the rod that is already have magnets on it, if you put the rod into the coil, what happens?
So first, for sure the inductance, but when it has a magnetic flux original on it, it will affect the initial voltage of that produced for the circuit, because
Can you see the result?
no, because the AC voltage is the frequency is so high that we cannot see the initial part of it. But I think that when it's opposite to the applied frequency, which the magnetic field is this in the inductor, and it's this direction in the rod, they will be dependent on it.
Compete with two magnetic field. One is the magnet produced by the rod, right? The other is the coil will create the magnetic field. What will happen?
There will be surely a initial big resistance due to the opposite magnetic field, but later
we'll discuss later.
And I think the coil and the AC current is the magnetic field inside is also changed. It's changed through the time, right?
Yeah.
And so when you insert the current, when you insert rod, the rod maybe can produce the AD current because about the flux density change. So make the AD current to against it. So it will make a new magnetic induced.
Have you ever seen that kind of experiment?
Yes, I do. But I will just do a ferromagnetic rod and melt it.
That's it. Okay, let's go to final. Okay. Okay, guys, the final one. The recorder 88876.
Thank you.
The reviewer.
Review.
Hold on. Sorry. 87877. And the reviewer. 74775. Okay. Okay. This is final. Then